I'll call the meeting to order, and it is my pleasure to be here today to introduce Gale. Gale goes back a long way. She was at YBRA before I got there. Then she actually TA'd out at YBRA for a year. And while I was there, I got to know some of the people at Penn, and she was one of the students then, and she came on to work with us. And she worked on a coal mine on the plateau and did some interesting work on strain and fossils, and then went on to work on fish and track thermal data plus H data for the Pennsylvania Basin. And it's, I think, a tribute to her work there that she ended up with the position she is in now. And you'll find that Gale is a very well organized person and has great people skills. So, Gale, welcome back to Penn State.
All right, thank you so much for inviting me here. This has been a really, really interesting series. I haven't been able to come up in person, but I've been listening to a lot of these talks through the series. I want to do something a little bit different, I think. So we've heard a lot of talks in this seminar series from a lot of people who are doing really, really interesting work, and we've heard from the people who are doing the work. I am not one of the people who's doing the work. So what I'm going to do today is give you kind of an overview of the work that we've been doing at the Pennsylvania Geological Survey. And I hope that what I tell you and the things that I show you will inspire you all who are listening, to maybe pick up some of those hints and go and explore them more, right? Because we're collecting a lot of information, but we're not the people who are going to dig into it as much as some of you who are researchers will be able to do that. So I want to start with just a little introduction to the Pennsylvania Geological Survey. So our field mappers are in the mapping division. Obviously, that to me is the bread and butter of a state geological survey. That's what we do. We make maps and we collect data. The groundwater folks and the geologic hazard researchers are also in the mapping division. Then we have a geologic resources division. Half of that is housed out in Pittsburgh, and that section does the oil and gas geology. So they do a lot of subsurface work. Then the mineral resources analysis section is in Harrisburg, and that's where our labs are and our geochemists are. And so the folks who did a lot of the work that I'll be talking about today are in that geologic resources analysis, mineral resources analysis section. Adam Iano is the supervisor of that section, and I'll be talking a lot about him. I'll be referring to him a lot. Then we have the Geologic and Geographic Information Systems Services Division, and they manage all our data. So we have obviously tons of data. They have our GIS people are in that division. They manage our databases. We have a library, a physical library with books and photographs and stuff. And we have a rock sample library, which I'll talk a little bit more about as we get farther on in the talk. Most of the work, so having introduced us, what I want to do today is to show you some things and hope that you'll be able to pick up some of these and move forward. So most of the work that we have done in critical minerals at the survey has been through the Earth MRI program at the USGS. And the next few slides are from their website. I just want to kind of give you a taste of what this program is like. So this was initiated in 2019 to kind of try to address the deficit of critical minerals extraction, mining, processing that was being done in the United States. That is, of course, the primary goal of the program, but you can see that it has all these other follow-on effects, right? So we're doing a lot of good geology, we're gathering a lot of data, and it can be used for other applications also. So there are multiple advantages to continuing with this program. Earth MRI collects a lot of different kinds of data. So if we go over here to topography, through the 3D elevation program, also in the USGS 3DEP, Earth MRI has poured a lot of money into collecting LIDAR in places that didn't have it. So a lot of the country was covered, but there were big patches that were not. And so places like Nevada didn't have it. Earth MRI bought it there. The geology and geochemistry part has been accomplished largely by grants to the state geological surveys. So we've done mapping and a lot of geochemical surveys. So that's done by the state surveys going out and collecting samples, and then we send them to the USGS, and they do the analyses in their labs and report the results. The USGS has been able to do some amazing large aerial geophysical surveys through Earth MRI. And I will spend probably the majority of the time today showing you some of the results of one of those big geophysical surveys here in Pennsylvania. The Earth MRI also cooperates with the National Geologic and Geophysical Data Preservation Program, NGGDPP, which is also a project of the USGS. And through that program, they've been able to send out, again, additional funding to the states to organize and preserve and update our data collections. And also, they've created a national index of borehole information. So there's been this is a kind of a survey of the different kinds of data that have been collected under this program. Here's the first 5 years. A little summary. You can see some of the successes. Started in 2019. We identified, the USGS got together with the states. We identified certain areas around the country to work on, different mineral systems that might produce the kinds of critical minerals that we were looking for. They started passing out money. The bipartisan infrastructure law in 2021 gave a huge infusion of money into the program. And that's when the USGS started to be able to do the aerial geophysical surveys. So that money is expiring, I think this year, I think is the last, or 2026 is the last year of that enhanced funding. And it'll go back, if nothing else happens, it'll go back to the base funding. But you can read on this slide some of the accomplishments, some of the things that have gotten done. And the next slide is this is a clip out of the document that the state geologists carry to Capitol Hill when we go to talk to legislators about why these programs are important. So this is from spring 2025. We went down in February. And these are just some projects that we chose to highlight. So the Pennsylvania underclays are on here. There is lithium in brines in the Smackover Formation. Apparently a lot of lithium in the brines in the Smackover Formation. There was this cobalt belt in Idaho that was revitalized, and a number of other things on here. So work's being done all over the country, and some really, really important and successful projects have been completed. The most recent addition to Earth MRI is the mine waste program. And this is to characterize geochemistry, unfortunately for Pennsylvania, only of non-fuel mine waste. the federal government has some territory, some territoriality in its agencies, and coal waste belongs to DOE. So the USGS can't fund research in coal waste. I put this picture on here. This also I took from the Earth MRI website. I put this on here as the illustration so that you can see the kind of mine waste that this program was designed to address, right? So it's sort of big Western metals mines. Even our Cornwall mine that we're so proud of and has such interesting things going on doesn't quite make what Earth MRI was trying to get at. So that's the Earth MRI program. And what have we done here in Pennsylvania? So the earliest work on critical minerals in Pennsylvania was probably these studies of underclays that were done looking for rare earth elements. These were done by DOE, and these illustrations here are from the International Journal of Coal Geology from an article published in 2003. So that's how long this has been around, right? So we've known that the underclays that are down here are pretty hot, right? So that's been floating around for a while. The big report on this study came out in 2014. I have this plot on here just to show you by way of illustration that one of the things that they found was that the rare earth elements are associated with aluminum. So that was an interesting discovery, and that is mirrored in further work. We keep seeing that. So as our first Earth MRI project, we went back and looked at those high alumina underclays. So technically this was not waste. We were actually looking at the clays. So we could do it under this program. And this was a geochemical survey. So basically what we did, there was no mapping involved in this. We went out and collected samples. It was a big joint project between 8 states. You can see them in the illustration here. It ended up that we divided into the Appalachian states and the Michigan or the Illinois Basin states, right? Because 8 states is really unwieldy to do a single project. So we were looking to evaluate potential for rare earth elements, for lithium, for other critical minerals. Some of these were samples that we already had in our collection. Some of them we went out and got new samples in mines and surface exposures. We ended up with about 1,000 samples, though. So it's a fairly large database of information that's out there now. This is one of the interesting, so this is the publication that came out of it, published by the West Virginia Survey. And again, here's one of the findings that the enrichment, this is a statistical diagram. So it's not a strict relationship diagram, but the idea is that the rare earth elements down here are associated again with aluminum and with phosphates. So that relationship is holding up. So that information is out there in this publication from the West Virginia Geological Survey. A project that we just finished, that we just published, was looking at for Cornwall-type magnetite skarns in the Gettysburg Basin, which is the southwestern extent of the Triassic basins in Pennsylvania. We published this beautiful map. It's a really nice map. It has some good cross sections on it. And this is an excerpt from this area up here, just to show you some of the interesting features. So this Hashard pattern here is the hornfells. These are the baked zones around some of the large diabase exposures. The pink is Jurassic diabase exposed on the surface, and there was some cooking of the rocks around those when they were intruded. So as best as we could, we mapped those baked zones, those hornfels zones, and put them on the map. Um, Wherever there were some mine adits or old pits, we noted those and the mineral that they were going after. So that information is all on the map. And then there are these blue lines that look like structure contours, but those are actually bedding traces that were visible in the LiDAR images. So we had really good new LiDAR for this area, and in the hillshades you could see bedding running through there. So that was helpful too in making the cross sections. So this map was just published a few months ago. Our current project is looking at Devonian black shales, so we've kind of moved away from the underclays, but we're looking at the organic black shales in the Foreland Basin. Some of the names of the units are illustrated over here in this cross section. So we're looking at the Marcellus, the Montango. These will be familiar to you if you've done any oil and gas work, Genesee, Rhine Street, Dunkirk. And this is Adam's language, potential for critical and critical-ish minerals. So we're taking samples and trying to find these other, how many of these we've got, right? So these are some preliminary results. This project is very much in progress. So what we've found so far is that the molybdenum, uranium, and vanadium are in the most organic rich layers. And something interesting that Adam Iano has proposed, is that lithium appears to be related to ash beds. So there are ash beds in the Marcellus. Some of the fluids may be interacting with those ash beds and leaching them and carrying the lithium out into the rest of the shale. But it appears to be ash beds that are maybe the source of the lithium. So this is his aluminum and lithium plot, and he may also is proposing that there may be a couple of trends. There may be this more horizontal trend and then this steeper trend. Not being a geochemist, I can't really tell you what that means, but anyway, it's something that's showing up in the data. And another thing that he has observed is that despite sort of conventional wisdom that pyrite has maybe some control over rare earth elements, he's found that that is not necessarily true. Pyrite, in what he's looked at, doesn't seem to have any control. It really seems to just follow the carbon. So Maureen is nodding. So that's good. All right. So I want to share this with you. This information was just published. So we did this aerial geophysical survey. It was about a $4 million study for aerial geophysics, magnetic survey and radiometric survey. This was the original footprint that was proposed, outlined here in red. And I wanted to show you this slide so that you could see the two mineral systems that we were trying to investigate. So we were trying to look at these Pennsylvania age underclays out here in the west, and then go across and look at Pennsylvania stream placers out here, because there have been, in the Piedmont, there's been some exploration that showed elevated rare earth elements in stream sediments. Nothing you're going to mine, but it's there. So where might it have come from? This is not what the final survey looked like because they had to know exactly how much money they had, and then they have to budget for helicopter versus fixed wing, right? So the survey has to be done at a fixed elevation above ground level. So you need a helicopter to go up and down over the ridges. And then in the more flat terrain in the east, you can use a fixed wing plane. So this was the footprint that we ended up with. Still pretty good. We got a lot of Pennsylvania in there and a lot of interesting areas. And then well down across the panhandle of Maryland and into Virginia and West Virginia. And this, okay, so this is the data. It was just published in September, so they got it out for the public to see just before the government shut down. I'm not sure, like I tried to get to the website. I can't use the data anyway because I don't have the right software. But I tried to get there and just look at whether you could download it, and I think it wasn't available that day when I looked at it. But if you want to see this, we can get it for you. So these illustrations are still the preliminary data, but they're, pretty good. So this is pretty amazing. You can ignore these two outlines. We'll come back to them later. But one of the things that I think is fascinating, just looking at the broad picture here, is how the different geologic provinces in Pennsylvania stand out here, right? So you have these broad anomalies out here in the west, and here's the valley and ridge. So this is up on the plateau. Here's the valley and ridge, and you get these linear anomalies through here. This is the Mesozoic Basin through there. This is this is South Mountain up here. And then this is the Piedmont. So like all hell breaks loose in the Piedmont. I don't know what's going on down there. But so they're all very distinctive though. So very distinctive magnetic signatures. This is the previous magnetic survey that we had. So when we've been looking at at magnetic data before, this is from the NURI project. This was a big national survey that was done around 1980. And we all thought this was really good, right? So just to orient you here, this is Lancaster County. This is York County. This is the Pennsylvania, Maryland line down here, Chester County on this side. So we're in southeastern Pennsylvania. So that's the old data. And this is the new data. So I can just do that a couple of times so that you can be duly impressed by this. We're going to look at some of these things in a little more detail. I want you to be as excited about these images as I am, and I want you to see things in here that we can do. Now here's the big test. Can I remember what all these things are, right? These obviously are the diabase bodies in the Rift Basin. So that's what we're looking at there. This big high over here is the end of South Mountain. So that's kind of interesting. This is a Cambrian sandstone coming up through here. If you're familiar with this is the Susquehanna River. This is Chickies Rock here, if you're familiar with the area. This big low is the Conestoga Valley. So these are carbonates here. This is the Redding Prong up here in the corner. And this is the west end of the Honeybrook Upland. So another basement body. The Redding Prong is a basement body also. And these are the schists in the Piedmont down here. And so it's interesting, there are these sort of swirly patterns in it, and then there are these linear patterns that come through that I would assume represent some kind of faults, some kind of boundaries of different blocks. And I really like that interpretation of them because when I mapped down here, I made a map of this, a bedrock map of this area. I don't know how long ago now. It was earlier in my career. And I put a big fault right through here. So based on what I saw in the field. So that makes me feel pretty good. So this is the kind of thing that you can see in the Piedmont. We can look, or in the southeastern part of the state, we can look in a little bit closer. These are some of the mines that have cobalt deposits: Cornwall, the Grace Mine, Gickerville up here. So these are all associated with magnetic anomalies. We would probably expect that. I have to give credit for these slides too, I'm sorry. These slides are taken from talks that were given by Angie Shaw at the USGS, who was the geophysicist on this project, chief geophysicist on this project, and Adam Iano at our survey also. This is back to the Mesozoic Basin, and the thin black lines, the thicker black lines on here are county lines. And this is the river. This is the Susquehanna River going down through here. These thinner lines are the outcrop pattern of the diabases. So those represent diabase at the surface. And you can see that there are some magnetic highs here that aren't mapped. So they're not appearing on the surface. So potentially we're identifying subsurface exposures of diabase. Interesting for potential exploration, but also interesting for water resources in the area, since people try to drill wells into diabase and they end up drilling very, very deep wells to try to get a little bit of water for their house. This structure over here, we've always sort of assumed is a sill. And the fact that there's this sort of diffuse high around it reinforces that, bowl-shaped sill structure for that. So we're going to move out to the west, and I'll kind of walk you through the panels on this slide. This obviously is the magnetic anomaly here, and this on the left is a model of the depth to basement that one of our people, our manager of the GGIS division, actually, Al Giuseppe, made from a whole lot of well data and seismic data and whatever other kinds of data we could get our hands on. So he made this depth to basement map. And so looking at these areas here, so we'll look at Indiana County. Indiana County is right there. And the contours on here are drawn from these depth maps, from this depth map. So it looks like there's some correlation of the magnetic anomalies with the basement features. So maybe there's some correlation. The broad magnetic highs may represent these basement structures here. So that's potentially another thing to explore. Now, this is in the Valley and Ridge, and this is a different filter. So we were looking at the big broad anomalies before. So now we're closer to the surface, right? So we're looking at short wavelength, shallower sources. So we see a lot of the anthropogenic features in here. You can see these little spots are like towns or mines or some sort of kind of like point features. These linear anomalies here are apparently wind farms. So the propellers, right? The windmills actually show up. And then these are pipelines. So this pipeline here, these linear features, this pipeline here. So all that shows up, as you might expect, in a shallow magnetic anomaly. But the really striking thing here striking, sorry, is these strike parallel bands that show up, right? All through here. And, so what are those? They don't really correlate to lithology. These are mostly clastic rocks in this area, so there are some limestone valleys, but they're pretty broad and they're not everywhere, and so we can't really match up these magnetic anomalies with lithology. So there's some thought that these could be, they could be from iron oxide and manganese veins, right? And there are a lot of candidates out there. These are mostly from the Silurian age Clinton group, clastic rocks. Some of these, as you can see, are quite broad zones of veining. Some of them are, narrower and more restricted. But there's a lot of it out there. So it's possible that these may be the culprits in those magnetic stripes. So the project that we are about to start, or I guess we just did start like the last month or so, is ground truthing some of those geophysics. And that's what these outlines are. So we're going to do a geochemical survey in this area outlined in orange to look at those iron and manganese deposits. And we'll also be able to characterize the entire Paleozoic section, which is exposed there from Cambrian up to Pennsylvanian. So everything is exposed at some place in that outline. So we're going to do a big geochemical survey. We're going to look for these other kinds of resources too. There's a little bit of the broad top coal basin that is caught in this outline, so we'll be able to do a little bit of underclay work there. I don't know that we've explored that particular basin before. We're also going to do this little sliver of geologic mapping to tie together a big project that we just completed over here in the Broad Top Basin and some other older mapping that was over here. So we're just going to fill in that little sliver there. So this will be pretty exciting, I think, to see if we can figure out what those stripes actually mean. We'll take a look at some of the radiometric data too. So we're looking at potassium and thorium here. This is back to Lancaster County here and York County here in southeastern Pennsylvania. This is the Susquehanna River, which you see as the white. So it's not very radioactive. That's good, I think. This big potassium signature is the limestone, the carbonate in the Conestoga Valley. You can see, again, the Mesozoic Basin going through here has a higher thorium value. This is South Mountain. So part of that, part of that is thorium, part of that has a potassium hit. Up here, the shales and carbonates in the Great Valley are, not so well discriminated, right, on the radiometric signature. If we go into the valley and ridge, we can see that the radiometrics really nicely trace out the structure. This is pretty dramatic. But interestingly enough, if we put the hillshade under that so we can really see the distribution of lithologies, they're not totally consistent, right? The quartz sandstone is pretty consistently low in both, but carbonates can be either potassium rich or thorium rich, and kind of the same thing with the clastic rocks, right? Some of them are thorium rich, some of them are potassium rich. The shales seem to discriminate by age. So there may be some influence of the I mean, I would assume there would be an influence of the depositional environment there. So that would be a really interesting thing, I think, to look into. Here is the results going out and using a spectrometer, at outcrop, point scale. And you see the same kind of thing here, right? So there are differences between the lithologies, but there's not good discrimination between the lithologies. So again, this is Alan Pitts, who's doing these measurements over here from the USGS. And this is the last thing I'm going to show you out of this series. So Angie Shaw noticed as she was going through here that there were these little local thorium highs, and these are associated with mines and or mine waste. So they appear to be places where the coal underclays were exposed during mining. So that's kind of interesting too. This is, again, you can see out in the west, right? Out here in the west. We just received notice that we're going to get another $4 million geophysics project that's going to connect our project down here in Pennsylvania to a previous project in New England. So this goes all the way from Pennsylvania across New Jersey and New York and nips the edges of Massachusetts and Connecticut. So this is going to be a pretty big and interesting project. Unfortunately, this was the proposed footprint. The actual footprint is smaller than this and cuts out the northern anthracite basin entirely. So sadly, because there's a lot of interesting stuff that's going on there, we won't be able to look at that. But we'll be able to look at these trends over here, a lot of the Mesozoic basins and the sort of that eastern front of the Appalachians goes through there. So we're excited about that. That'll start sometime in 2026. All right, so I mentioned that I'm hoping that some of these things will spark something in you that you might want to think about working on or collaborating with us with. So what could we bring to a collaboration as the Geological Survey? We don't have a ton of money, but we have a lot of other resources. So we have approximately 200 years worth of investigations into the geology of the state of Pennsylvania. You can find our most recent work from what we call the fourth survey. So a lot of the 20th and 21st century work is on PA Geode. This is our web mapping application. There is digital data from our most recent work, and everything else, all the other maps, there are at least PDF scanned versions of those maps and reports. So you can find pretty much all of our stuff here on PA Geode. If you want something older and you can't find it here, you can contact our librarian. She's very good, and she will get you a copy of, the 1870 first survey publication that you're looking for.
What date are you talking about?
Excuse me?
What date?
Oh, this is done. This is up. We've had this out for a while. We also have our rock sample library, and I believe we have something like 14,000 feet of core in our, it's got to be more than that. Anyway, maybe it's 14,000 boxes. It's a lot. We got a lot of core. And these boxes over here are cuttings. So we have, again, it's in the notes. I don't know exactly how many cuttings we have, but we have a whole basement full of cuttings also. Most of this is in our office in Harrisburg. Tim was just down there this morning. Tim White was down there this morning picking up something.
Good luck ever getting that.
So most of it, most of the collection is in our Middletown office just outside of Harrisburg. There's a little bit out in Hollywood in Clearfield County in Western PA, and there's a little bit at Raccoon Creek State Park, even that's out near Pittsburgh. That's cuttings that's out there. So all of this is available to you if there's anything that you would like. We don't have these collections digitized yet. So if there's something that you're interested in, if you contact John Newbaum, who's or contact me, contact the survey. John is the librarian of the rock sample library, but we will look through and find out if there's something that can help you. This is probably our best resource, though, is our people. We have about 34 people on our staff. Most of them are geologists. And if you put all of these heads together, we know more about the geology of Pennsylvania than any place else that you're going to go. So if you have questions, start with us. And we're happy to help out and collaborate in any way that we can. And that is the end.
Great. Thank you, Gale. Do you have any questions?
Gale, thanks. That's great. I'm wondering about the accessibility of the geophysical data. Can anyone get it, or do you have to work with somebody at the survey to do it? Can companies purchase it? I'm just curious what accessibility is.
The aerial geophysics, that is publicly available because of it's USGS data. So kind of like us, the government collected it. It's available for you to use. I can get you the link if you would like that. I think you can get to it through the Earth MRI website, but Angie did send us links.
So it's an open repository and people can just download the data?
Yep.
Wow.
Yeah. Pretty cool, huh? That's what the government does for you.
Yeah.
Your tax dollars at work. Yeah.
You mentioned with Earth MRI that in terms of mine waste, you could only do non-fuel related.
Right.
And I'm just curious, have you guys done anything with fuel related mine waste? Have you thought about it at all, mapped it, done anything?
We have thought about it. Yeah. But no, we haven't actually mapped it. I believe there might be a little bit of work on trying to locate mine dumps, just kind of map the mine dumps that we were doing as part of a larger grant from DOE. But I don't know what the status of that is right now. I can find out what that is. No, we haven't done anything with that. That doesn't mean that we couldn't. We just haven't invested in that. But, we'd be happy to work with somebody if you want to look into that.
Question if people do you have a question? I'm just curious, the areas that you show all these exciting geophysical features in, some of them are pretty heavily populated.
Yeah.
And have you done any sort of overlays and said, yeah, this looks interesting, but forget it, there's a town there?
Well, I think that's most of southeastern Pennsylvania.
Yeah.
Like you can't do any mining there.
Mm-hmm.
But I'm super interested in the geology there, right? For other reasons. Like we talked about water resources.
Mm-hmm.
It's very important for understanding what the groundwater does. And, I think that we have found over the last several decades that we never know what geologic information somebody's going to find useful in the future. We had a bunch of data from northern Pennsylvania, and nobody cared about northern Pennsylvania. Nothing lived there but deer and elk and bears. And suddenly, everybody wanted all of our information, anything we had from any place that might have gas underneath it. Right? So that, those cores had just been sitting there for 20 or 30 years and nobody cared about them. And suddenly they did. So I'm, excuse me, all about collecting geologic information wherever we can, because we don't know what we might find a use for in the future.
Oh, do you mind if I just ask, since I have it? Well, actually, Tim's question about the energy, fuels-related waste. I'm just wondering, with the aerial surveying that you've done, and you had picked out a clay mine waste, high thorium, I guess. I'm just wondering if the data aren't there, at least for the regions you've done the survey, it's just a matter of looking, finding the signature for it, and you could use then the data to extract what the distribution of that mine waste is.
Yeah, and all that,
it's there.
It's there.
Yeah,
it's just waiting.
And he's going home to download it. Good. I'm curious about what's known about the iron and manganese veining in that's Nivalian Ridge, right?
Yeah.
Yeah. Is there been a history of study of that I
Not
should
really.
be aware of? And,
no. I don't think there has been. I'm sure it's been noted.
Yeah.
Because we know Clinton groups. There's a lot of, but I don't know that it's ever been explored.
Yeah.
I think there has been some mining in that area.
I'm just about the history, like when the fluids move through there. Yeah. Is it restricted to the Clinton? So it's slurry and fluid movement as well?
I think it's restricted to the Clinton. Yeah. I think that's just where, probably because of lithologic constraints, and that's where the iron is.
What's that? Well, yeah, there's the iron oolite.
Yeah.
The Clinton iron ore.
Yeah.
Right. Yeah. Yeah. So maybe just that's the source that migrated.
Yeah.
From there.
So, no.
Manganese, Peter.
Yeah. Yeah. So, there may be some information in the literature. I haven't dug into it, but I don't there hasn't been a lot of systematic exploration of those.
Gale, thank you for the presentation. The data are an invaluable resource, and the images that you're presenting were fantastic. I'm not an expert at all on magnetic surveys, but it seems there's a potential for being able to do things with it. It's exciting. But I wanted to ask you about your very last, slide about the resource and human capacity you have and knowledge base that you have there. Mm-hmm. What are some of the most successful models of engagement with that resource when it comes to establishing partnerships, collaborations, bringing people on proposals, projects, or even engaging in helping with graduate student training? So how do we tap into that resource and collaborate in some way that is mutually productive?
Well, we have a lot of interns every year, and those would be undergraduate, and we can have graduate students also. We have usually about a dozen in the summer. And because, Penn State's pretty close, if they were willing to drive back and forth, or maybe there are things that they could do somewhat remotely, right? If they just came down periodically, there is an opportunity to have interns throughout the year, right? It's not just restricted to that. We've had some successful partnerships with other schools. We've done a lot of work with Lehigh University with Frank Pizzalia, some of his doing the terraces, stream terrace work. We've worked with him on that. Some other surficial mapping, some of the glacial mapping. We've been partnering with Wilkes University. It's helpful, I think, if there are students involved, right? Because then the students can get the benefit of the professionals who are, in the field working. Right? So those have been good. We also have a lot of interstate cooperation between the geological surveys, and there's a very close relationship between the USGS and the state geological surveys. So, we wouldn't limit it. I wouldn't limit it to a certain kind of work, right? Because we do a lot of things, and we had a project where we were generating a digital surface at the base of the Triassic Basin, the base of the Mesozoic Basin. And we had a lot of cross sections that had to be digitized. And so we were able to contract with Harrisburg University. And there was a geologist who was there who had his students do all that digitization. And they worked closely with us so we could keep an eye on it. And so we knew they weren't like doing something crazy. And they also learned, a little bit about the geology and a little bit about that kind of work. And questions, people like Tim's been coming down and picking people's brains about the work that he's doing. And, you can just call somebody and, I want to know about the Devonian. And there's somebody who will talk to you about that.
I'm just I'm thinking about the black shale work that you're just starting now and metals. And is there thoughts about that from leaching of metals potentially using existing or hydrofracturing? I'm thinking about the extraction part of that. Is it motivated by that sort of thing? In situ extraction of metals? Is that an end game?
Well, right now we're just trying to find out what's there.
Right.
But there could be many end games to using that data.
Right.
Right.
Yeah, and so your data gathering, is it based? It's on core and mostly core data. Then you're doing.
We have some core that I think we're going to use, but they're actually planning to go out and sample
surface
samples.
Yeah, outcrops.
Right. Well, it's about 5, so we can end there. Thank you, Gale.
Thank you.
And Gale's talk will also be posted to the EASY YouTube channel. And then next Monday, we have Nicholas Sullivan and Timothy White will be speaking for us Monday. Thank you.